You'll take the high road, I'll take the low road. I'll be in Scotland before you. Sometimes there's more than one way to get someplace. And picking one road versus another might be about which is faster. It might be about not taking the road that's already really busy. And it might be not taking the road that was closed because of a mudslide. So with the bonny banks of Loch Lomond behind us, let me just say, in NSX, we can set up more than one router as a way to get out of our distributed logical routing environment. And when we do that, we can enable a service called equal cost multipath routing, which will give us the high road and the low road. It'll give us the tools to be able to have load distribution and failover in case one of our edge routers should go down. To get some experience with ECMP, we're going to go ahead and head over to the VMware hands-on lab, specifically the starting lab 1903, fire up the Google Chrome browser, log on to the vSphere web client as administrator at vSphere.local. Let's click the home button and head down to networking and security. And ECMP is all about routing. So let's head over to NSX Edges where we manage routing. The default lab environment supports our data center being connected to by an Edge Services Gateway. That's this NSX Edge that we see right there, which is providing some basic routing. Then underneath that, we have access to Distributed Logical Router. What we're going to do in this lab is create an additional Edge Services Gateway that can provide that same functionality to enable the distribution of routing up to the data center from the DLR. So the DLR will have multiple options, multiple paths because of equal cost multipath routing. And all of this is to the benefit of the VXLANs, those logical switches that are uplinking into this DLR, not for when they communicate to each other, but when they need egress out of the DLR network. Let's create a new NSX Edge that mirrors the perimeter gateway that we currently have. We'll click the green plus. This is going to be an Edge Services Gateway. We're going to call it P2 for Perimeter Gateway 2. Put that in as the host name. We are going to deploy it. We're not worried about high availability or logging. We'll click next. Let's put in the password of VMware1 exclamation point, VMware1 exclamation point for the password and confirmation. We'll enable secure shell access and leave the rest with the defaults. Then we'll click next. We'll leave it as a compact device. Click the green plus to add it. When we think about adding a second edge device for load balancing and failover, we may want to support that even in a separate cluster. For now, we can use the same cluster that we're already using. And we're going to use the iSCSI shared data store. Another option we might choose might be to assign it to a specific host where the existing edge appliance is not, or better yet, to actually set up VMware policies that prevent the two edges that are supporting each other from being co-located. For now, we'll leave it with the defaults and click OK. Then we'll click Next. We'll need to configure some interfaces, so let's click the green plus. Our uplink interface is going to be named Enterprise Uplink. Leave it as the uplink type. We'll click select. And then we're going to head over to the distributed virtual port groups. We'll select the uplink region A1 VDS-MGMT interface and click OK. Then we'll need to give it an IP address. So we'll click in the blank there and put in 192.168.100.10 with a subnet prefix length of 24. Then we'll click OK at the bottom. Then we'll click the green plus once more. And the name for this interface will be the transit interface. We'll make sure it's an internal interface because it's going down to the DLR. We'll click select for connected to, and we'll choose transit network 01. Then select OK. We'll need an IP address here. We'll click the plus, and we'll add the IP address of 192.168.5.4, which is an available IP address even with a subnet prefix of only 29. Once 29 is entered, then we can click OK. Then we'll click OK from here. Next, and we're going to uncheck Configure Default Gateway, click Next, and we will go ahead and configure the firewall policy with Accept and Enable, and then click Next, and then we'll click Finish. Now we have our two NSX edges with logical connections to the DLR, but we're going to need to get them all to inform each other about their routes using a dynamic routing protocol. In other nuggets, we've gone through the process of exploring OSPF and BGP as dynamic routing protocols, so I'm going to speed run through the demonstration of that process right now. Notice we're configuring the DLR with BGP neighbors of both 5.1 and 5.4. It's going to be important that we use enable default originate to ensure that our routes have an equal cost between our two paths. So for this lab specifically, we're going to use the enable default originate. we enable BGP on P2, we're going to also enable default originate and also place it within the same autonomous system of 65001. All right, our BGP configuration is complete. From our home menu, let's go down to VMs and templates so we can take a look at what's going on in our routers. And let's select the DLR itself. And on the summary tab, we'll click the thumbnail to log in. Spacebar to wake it up, type in admin to log in, and VMware 1 exclamation point, VMware 1 exclamation point. Let's type in show IP route. And we can see we are only learning about one default gateway route, the all zeros default gateway route coming from 5.4. But we've got all these other routes coming from 5.1. Is 5.1 not presenting a default gateway? Let's check. If we do show IP BGP, we can see all the information that is in the database, and notice that there are two default gateway routes, one pointing to 5.1 and one pointing to 5.4. But by default, even if all metrics and weights and preferences based upon the dynamic protocol are equal, the DLR is forced to choose a single best route. So how do we fix that? We're going to enable ECMP. Let's go back to the vSphere web client, and we'll head up to the home menu, down to networking and security. We're going to open up NSX edges on the left, and then we'll double click on the distributed logical router. Once we're there, we'll head back to the routing tab, and under global configuration, there's a gigantic start button that we're going to click. So this is a service that we're actually going to start. We'll publish the changes. Now that we've started the ECMP service, let's go back to our DLR tab that we have open in the browser, show IP route. And what do we see here? Two default gateways. So we have achieved what is known technically as load balancing. Huzzah! And that's going to be especially important when we think about these different edge services gateways and their need to perform, for example, perimeter firewall configuration, maybe network address translation from this point. So there's extra workloads going on in those gateways, and so being able to have more than one to balance those processor and memory level workloads can give us noticeable improvements in network performance. We said the other aspect of this is failover support. So let's test that. We'll go back to the vSphere web client, and let's go to VMs and templates from the home menu. And let's simply right-click on P2, head to power, and suspend it. So we're simulating a failure of a virtual machine or the host that the virtual machine might be running on. Let's take a look at what's going on in the DLR. We'll up arrow, show our IP route, and currently we are still seeing that route in place. Now, why is that? Because the equal cost load balancing is based upon our BGP protocol. So what has to happen before this BGP route is going to disappear? The dead timer associated with BGP is going to have to expire before it'll remove this route for us. And that really is normal expected behavior in the world of routing. If we want to see where we're at in that, we can type in show IP BGP neighbors. And relative to that neighbor, we have a hold time of 180 and a keep alive interval of 60 seconds. So every minute it checks to see if the other router is still alive, and after 3 minutes, that hold time will fail over. Now, BGP configurations can be altered, and this is one of those times when OSPF has a much faster timer, which is based upon a 10-second interval to communicate with a 40-second dead timer interval. Let's up arrow and run that command again. Aha! Notice that we have down at the bottom an error saying hold timer expired. So now let's see what show IP BGP displays. Notice only a single connection. The BGP information from 5.4 is no longer valid, and so it's been removed from the database. And if it's been removed from the database, then if we do show IP route, sure enough, we're down to a single router. But as soon as P2 comes back online and can start communicating again, then we will be able to resuscitate that information. And after a minute, we can see we're back there with show IP route. We can see we now are equal cost multipathing. Now, I did want to mention in this case, we were using a DLR and BGP. This would work equally well with OSPF. This can even work with static routing. And this was an example of ECMP routing from the DLR to a couple of edge services gateways. But if those edge services gateways need to have their own ability to perform equal cost multipath routing to other physical routers that are attached to the network, we can enable ECMP in the same way on our edge service gateway devices right there in the general configuration of our routing tab. My friend, by going through this nugget together, you've learned that if you set up support to point to more than one router, more than one gateway to get to a certain network, by default, the router will simply pick one route to get there at a time. But if we enable ECMP, multiple routes can load balance across those different paths, and we can have a source of failover in case of a loss. I hope this has been informative for you, and I'd like to thank you for viewing.